Farming techniques are fundamental when it comes to crop yield and efficiency. As we enter the modern world, modern farming techniques are introduced with the use of advanced technology and takes conventional practices into another level and extraordinary way. Hi, I am Kian Eric P. Ganza, Bachelor in Agricultural Technology student, and here is my presentation about aeroponics as an advanced technology for potato production. In this presentation, the contents consist of introduction, components of aeroponics and their operation, planting materials, temperature adjustments, light and humidity requirements, spray mixtures and droplet size, pH and AC measurements, harvest and handling of mini tubers, advantages and disadvantages of aeroponic system, and also conclusion. So, for introduction, potato is a cash crop and one of the significant part of the global diet. It requires deep, loose, well-drained soil that is free from stones for good tuber development. However, low soil fertility, soil-borne diseases, poor water quality, and pests seriously affect the potato production in developing countries. To improve potato quality and the production, it is necessary for modern world to improve its potato cultivation techniques with the use of advanced technology. So, as we know, potato is a cash crop, root crop, which grows annually. It is cultivated in the soil in order to grow, but there are some factors that affect its production. It includes low soil fertility, soil-borne diseases, poor water quality, and pests. To fix this, advanced technology made a significant change on how these things works. So, what is aeroponics? Aeroponics was derived from the Latin words aero, which means air, and ponos means work, and literally means air work. It is the method of growing plants without soil where the roots are exposed to the air. Yes, you heard it right. Aeroponics grows the plant without soil and just exposing it to the air. It is because it is grown in indoor area and under controlled environment. The soil is replaced by foams or plastic stands and roots are suspended in open air under controlled circumstances. The nutrient solution is spread through atomization nozzle, which absorbs by the plant efficiently and sustain growth. Amazing, right? Components of aeroponics and their operation. Aeroponic system composed of several important parts, such as reservoir container, nutrient pump, mist nozzles, tubes, grow baskets or pots, enclosed growing chamber, water weight container, plant supporting tray, control system, and timer. All of these are built in an automated aeroponic growing system. So, this is the diagram of an automated aeroponic growing system. So first, let's take a look at the outside parts. So, as you can see, plant is at the upper part of the rectangular chamber or the growth chamber, and there is a plant holder as well as plant supporting tray. On the right side, there is a timer and pump. On the left side, there is a control system which consists of light intensity sensor, humidity sensor, and temperature sensor. On the inside, it has the nutrient, where the nutrient solution is placed. Also, the nozzle and the spray of the nutrient solution. A light source, especially LED, enables the plants to photosynthesis and store energy. So, light source is placed at the top and imitates the characteristic of the sun. It provides energy which is responsible for photosynthesis process. The plant supporting tray separates the plants from their roots. Plant supporting tray is placed at the middle as division of tuber stem and roots. A nutrient-heavy mist in the solution chamber is absorbed by the plant's root system. So it's the lower part of the chamber where nutrient solution is sprayed to the roots. Planting materials. In vitro mini tubers are the best planting materials used in aeroponics of potato. Plant material should be free from diseases such as root cap, root cut-up, and tuber buds. So mini tubers are the planting material used by in vitro method, specifically tissue culture, where individual cells or parts are cultivated under nutrient media under sterile laboratory conditions. Temperature adjustments. In aeroponic systems, temperatures of the nutrient solution and air must be controlled. During daytime, temperature should not be higher than 30 degrees Celsius or lower than 4 degrees Celsius for potato crop for tuberization. In nighttime, 10 to 15 degrees Celsius are recommended. It is important to about adjustments of temperature because the chemical process proceeds at a faster rate and deteriorates the enzyme activity when the temperature increases. So next, light. For potato crops, light energy is an important environmental factor required for controlled cultivation. The light intensity and quality not only provide energy, but they also provide for a large number of morphogenesis and physiology-related responses during plant growth. So like I said earlier, light imitates the characteristics of the sun, which is responsible for photosynthesis process. And LED is considered as the best light in aeroponic systems. So humidity. Increases and decreases in relative humidity seriously affect the plant growth. It affects the physiological functions and causes diseases problem. It is very convenient to control and maintain humidity in the growth chamber on a regular basis. So as this farming technique grows in a controlled condition, it is important to maintain the optimum relative humidity to sustain an ideal moisture inside the chamber. Fluctuation of humidity can cause detrimental effects on the crop. Spray misters and droplet size. In aeroponic system, the roots of potato receives the nutrient spray mist. The atomization is divided into high, medium, and low frequency atomization. The droplet size ranges from submicrons to thousands of microns. So when we say microns, it is a very tiny particle droplets. It is categorized as a finely atomized mist of 10 to 100 microns from high pressure atomizing nozzles. pH and EC measurements. So first, what does pH and EC means? pH is the level of acidity of water, while EC stands for electrical conductivity. It is the measure of the amount of electrical current a material can carry or its ability to carry a current. The pH and EC of a nutrient solution can be easily measured with pH and EC meters. In this system, pH of the nutrient solution does not exceed 7.3 when matter and nutrient solution are recycled. Therefore, the ideal pH values are 6.5 to 6.8. However, the optimum EC values of the nutrient solution lie between 1.5 and 2.5 dsm raised to -1. Harvest and handling of mini tubers. Early maturing potato varieties begin to produce mini tubers after 2 weeks of transplanting. When the mini tubers reach at least 8 grams or are equivalent to 0.5 cm in diameter, it is best to harvest them. However, remove all the mini tubers with the diameter greater than 1.5 cm during the first harvest to enhance the start of more tubers. After 10 to 14 days, subsequent harvests may be performed. The harvest lasts until the plant reaches approximately 6 months old. So, as you can see, harvesting is early in the system due to its controlled environment and efficient distribution of nutrients. It allows the potato crops to grow rapidly in a short duration of time. So, advantages. So, here are the advantages of aeroponic system in potato production. So first, higher yields. In comparison between traditional farming, this system can produce 3 times higher quality yield. It's because crops receives total packaged nutrient constantly without any biological interruption. So next is, can be used effectively in many areas. So as vertical farming implemented in some developed countries, crop production is applicable even in urban setting. Land areas are not a problem in this system. Water requirements are very low. This closed-loop system uses 95% less irrigation than crop grown in soil. Since the nutrients are held in water, they get recycled too. No seasonal adverse effects. This system works in indoor area and controlled environment. Optimum temperature are set as well as relative humidity, light, and water. Therefore, hot, dry, cold or windy weather are not an issue and crop can be planted all year round. Shorter growing cycle. So as the planting material used in this system are by in vitro culture of mini tubers, early maturing varieties are selected. Therefore, shorter growing cycle of the crop are expected. Free from insects and pests. It is one of the major advantages of this system because as the crops grown in indoor area, the strike of microorganisms are inhibited. Also, the use of pesticides are restricted, which can save a lot of cost in the production. Free from soil diseases. So basically, it cannot acquire soil diseases because soil is not part of the system. Utilize less spacing. Due to vertical farming techniques, it takes small spacing for a large production. Instead of consuming hundreds of hectares of land, the production operation runs by vertical tower which are space efficient and suitable in urban regions. If there's an advantage, there's always a disadvantage. So these are the disadvantages of aeroponic system. First, expensive setup. Initial setup for this system is quite expensive so that a small-scale farmer could not afford it. One of the current systems that are available for sale right now includes a double-barrel 32 structure with 8 side lids. It is built to order, ships on pallet, and will cost over $12,000 or 629,106 pesos to secure. Next, requires constant monitoring. Although the work is easier when taking this approach to growing crops, aeroponic requires more time and attention to ensure a successful result. The crops must receive constant attention to their pH levels because there is not growing medium available to do this work. Producers must also track the nutrient density ratio because of the sensitivities naturally built into the system. Highly susceptible to power outages. Losing electricity have a huge impact in this system. Misting, water access, and fogging must occur frequently to prevent the roots of the crop from experiencing desiccation. If the system goes offline for more than a few hours, it becomes possible to lose an entire crop. And lastly, it requires certain level of technical knowledge. Aeroponics requires grower to have a particular level of technical knowledge to be successful with this endeavor. The construct need to follow a specific setup process because there is no growing medium available to absorb any excessive nutrients. It is up to each producer to know how much each crop requires daily to produce the maximum amount of fruit or vegetation. Giving the plants too little or too much water or nutrients can produce undesirable results. Those are the advantages and disadvantages of aeroponic system. Now, let's take a look at potato production using aeroponic system looks like. As you can see, the yields say it all. It shows how effective and productive the crop will be under this fantastic system. Also, as you can see, the crops are hanging inside the chamber to gather its roots and no soil are used. To conclude, aeroponic system appears to be the best system for potato production, especially in areas where soil and water are in critical condition. The system significantly increases potato production compared with the other system currently in use and also provide protection from pests and soil-borne diseases. However, initial investments are pretty high but the output will become worthwhile in a long-term production. So that is the end of my presentation. Again, I am Kian Eric P. Ganza. Bachelor in Agricultural Technology student, and this is aeroponics as advanced technology for potato production. Thank you.